morning, students. Welcome to the next session on programming for problem solving using C. So today we are going to discuss about files in C language. Right. So what is file? So file is collection of related data. File is nothing but collection of related data treated as a unit. So file is an external collection of related data treated as a unit, right? So normally in a file we are storing the data, right? So the aim of the file is to keep a record of data. So normally the programs so far we have discussed is, so after executing the program, so the program, whenever the program is executed, that is currently stored in the main memory. The output cannot be stored. The output will be erased whenever the computer is shut down. The memory contents will be erased. To store the data permanently, right? To store the data permanently, we can use a file concept in C language. With the help of file, we can store the data permanently in secondary storage. Secondary storage is the permanent storage device. So with the help of files, we can store it in the secondary storage, right? So the contents of primary memory will be lost when the computer is shut down. We need files to store data in more permanent form. So the collection of data is often too large to reside entirely in the main memory at one time. That is why we are going for secondary storage for storing the files. So files are stored in auxiliary or secondary storage devices, right? So the two most common forms of secondary storage device disks are hard disk, CD, DVD and tapes. Disks and tapes. Disks like hard disk, CD, DVDs and tapes, magnetic tapes, optical tapes like that. So the stdio.h header files define the file structure. So file is defined data type. So file is a defined data type which is defined in stdio.h header file. When we need a file in our program, we need to declare it using a file type. See here, file star sp, where sp is a pointer to the type file. Right. So here streams. You see, here this is the program, right? So these are this is a keyboard input device file. So we can, the program can take the data from either input device keyboard or from the file, right? The program can take the data from a keyboard or a file through input text stream. It is the stream, input text stream. Stream is nothing but sequence of bytes. It can take character by character. So here the program takes the data through the stream from keyboard and file. When the program takes the data, so these are the sources, data sources. So the data will be taken from either keyboard or the file. So when the program supplies the data to the file or monitor, so these devices will act as data destinations. So the data will be transferred from data to the file or monitors. Here monitor and file are the data destinations, right? So the data will be transferred from program to the devices using output text stream. This is another stream. So input text stream, output text stream, right? So when the data is supplied by the program to the monitor or file, then so these devices are the destination devices and these are the source devices from which these devices the data will be supplied to the program. So to these devices the data will be supplied from the program. So stream is nothing but sequence of bytes, byte by byte it can take, right? So the program can take the data. Program will supply the data to these devices, right? So the program will take the data from the keyboard byte by byte. So through input text stream it will be transferred, right, to the program. So and also program will take the data from the file, right. So in the similar way, the data will be transferred from the program to the monitor. Program data will be displayed onto the monitor. At that time also, it will be transferred through output text stream. And also we can store the data into the file. So at that time it will be transferred through the output text stream. Now, the difference between text files and binary files. So we have two types of files. One is text file, another one is binary file. So in text file, everything is stored in terms of text. Everything is stored in terms of text. That is, even if we store an integer 54, it will be stored in the form of text. You see here 54. So this is like a string, right? String is nothing but sequence of characters, and the last character for the string is null. So it can be stored in 3 bytes. So for storing 5, it takes 3 bytes. For storing 4, it takes 3 bytes. For storing null value, it takes 1 byte. So totally, so for storing 5, it takes 1 byte. For storing 4, 1 byte. 0, another. So totally 3 bytes. So in case of text files, the 54 will occupy 3 bytes. 3 bytes, right? So binary file contains data that was written in the same format used to store internally in the main memory, right? So in the binary format, the data will be stored. For example, if you want to store 54, that 54 is the decimal number that will be converted to the binary and it will be stored. Here integer number, it is integer number. Suppose integer occupies 2 bytes, means within 2 bytes we can store it. Within 2 bytes we can store it. So for storing 54, in case of binary files, it takes only 2 bytes. In case of text files, it takes 3 bytes. Right? Suppose if you want to store 1, 2, 4, 5. In case of binary, it takes only 2 bytes, right? Because it is an integer. So integer number will be stored in 2 bytes. Whereas in case of text file, it takes totally 5 bytes. Because there are 4 characters. For each character, it takes 1 byte, and one more character text. One more character is null character. For that also 1 more byte. Totally 5 bytes are required for storing that. See here, this is, suppose it is a short int. I want to store 768. A, character A, I want to store. In case of text file, how it will be stored. In case of binary file, how it will be stored, we will see now. So 768, the ASCII value. So here, for each character, 1 byte is required. So the ASCII value of 7. See, for 0, the ASCII value is 48. 1, the ASCII value is 49. For 2, ASCII value is 50. 3, ASCII value is 51. For storing 4, ASCII value 52. 5, 6, 7, 8, 9, and so on. 53, 54, 55, 56, 57. See, here 7. The ASCII value of 7 is 55. So the binary value of 55 is this one. Next for 6, it is 54. For 8, the ASCII value of 8 is 56. Right, next character is A. So A can be stored like this. The ASCII value of A is 65. So its ASCII value is stored. Right? So how these two values are stored in text file? So like this. So it occupies totally 4 bytes. 4 bytes. In case of binary file, the 768 directly converted into the binary form. 768 directly converted into the binary form. So it is a short integer, means short integer occupies 2 bytes. Within the 2 bytes, we will store 768 value. 768 value can be stored in 2 bytes, right? Coming to A, its ASCII value, it is 65. If it is character, its ASCII value can be stored in case of binary file also. in case of integer and all, so directly it will be converted into that decimal value will be converted into the binary and it will be stored. Right. Now, file operations. C supports a number of functions that have the ability to perform basic operations, which include naming a file. Suppose you take notebook. Notebook is having a name. It is a file. So in the notes, we are writing the subject matter, right? So here first naming a file, then open the file, then reading the data from the file, writing data into the file, finally close the file. So these are the operations which are to be performed on a file. First we have to name the file, then we have to open it for performing either reading or writing operation onto the file, and finally after performing the operation we have to close it. How these operations will be performed we will see next. So there are two distinct ways to perform file operations. First one is the low level I/O, and it uses Unix system calls for this, but this cannot be discussed in our files. The second method we are using. So the second method refers to the high level I/O operations and uses functions in C standard I/O library. So about this second method we are going to discuss. Now, disk I/O functions. They are high level, low level. So coming to the high level, there are two types of files: text files, binary files. So for text files, so formatted, unformatted. Formatted I/O functions and for unformatted I/O functions are there. Formatted I/O functions are fscanf, fprintf. With the help of this fscanf, we can read the data like integer data, floating point data, double data, character data, string data. That data will be read from the keyboard. Program will read the data from the file. So scanf is used to read the data from the keyboard, whereas fscanf is used to read the data from the file. Next, fprintf. Printf is used to print the data onto the monitor, whereas fprintf function is used to print the data into the file or write the data into the file. Next, unformatted I/O functions. Unformatted I/O functions like fgetC to read the character from the file, fputC to write the character into the file, fgets to read the string from the file, fputs to write the string into the file. So these are the functions which are used in text files. Coming to the binary files, again formatted and unformatted are there. Coming to unformatted, we have two functions, fread and fwrite. Fread and fwrite. So in our syllabus, we have to go through the programs on these. First, formatted, unformatted, and unformatted in binary. So we'll discuss on that. First, file handling functions. So what are the functions for handling a file and its operation? We'll see now. First one, fopen. Fopen function. So creates a new file for use and opens an existing file for use. So it is used to create a new file for use and also opens an existing file for use. Right? It will open a new file or existing file. Fclose function, it is used to close the opened file. So close a file which has been opened for use. After using the file, we can close it. So if you want to use the file, first we can open it, then perform some operation. After that, we can close it with the help of fclose function. So getC. So this reads a character from a file, getC or fgetC. Next, fputC. It is used to write a character to a file. Fprintf. So writes a set of data values to the file, reads a set of data values from the file. Now getW. This function reads an integer from a file. PutW writes a integer to a file, fseek, it sets the position to a desired point in the file. Suppose you are currently the file pointer at position 2. If you want to move that file pointer to some 10th location, then we can move it with the help of fseek. We can move it either forward or backward with the help of fseek. Next, ftell, this function gives the current position in the file. So currently the file pointer where it is, right? And which byte it is, and which position it is. Next, rewind sets the position to the beginning of your file. So this function is used to set the position to the beginning of the file. Now we'll see. So whenever you want to perform file operations, first you can use a file pointer. See here, it's a predefined data type file, and its pointer is *sp data. So sp data is the pointer to the file. Pointer to the file. It is internal file variable. Pointer to the file. Right? With the help of the file pointer, we can open the file. So fopen off. So here mydata.dat. So .dat, it is an extension. .dat, data file. .c, C file. .txt, text file. .cpp, C++ file. .java, Java file, like that. So my data dot. So my data is the file name. So data file name. So W, nothing but writing mode. So here we are opening my data file for performing write operation. That is the meaning, right? See here. So that file, see here, this is the file pointer sp data. We have a file. Its name is mydata.dat, this physical file. So the data will be stored into the secondary storage. The data will be stored into the secondary storage with the help of this. So data. So whatever the data we have written, so that data will be stored into the secondary storage. Data will be stored into the secondary storage. So how it will be transferred? Using the stream. We have the stream. So data will be transferred to the file or from file to the data. Right? So the stream will act as either input or output. So when the program takes the data from this file, it is acting as an input stream. When the file takes the data from the program, it will be acting as a output stream. So we are opening the file in different modes, 3 modes: read mode, W, write mode, A, append mode. So first R, mode, it is a mode. So here it is the mode. It can be anything. R, open a file in read mode. If the file exists, the marker is positioned at the beginning. If file doesn't exist, return error return. W, open text file in write mode. If file exists, it erased. If file does not exist, it is created. A, open text file in append mode. If file exists, the marker is positioned at end. If file doesn't exist, it is created. Right? Okay. See, suppose reading mode. It's writing mode. It is append mode. Reading mode. Open existing file for reading. So already file is there. So EOF is the end of file marker. EOF is end of file marker. So when we are opening a file in reading mode, initially the file pointer points to the first position. So file marker position at beginning of the file. So from here it will read character by character. So after reading this character, again the file pointer is moved to next character. Again next character. After reading this next character until it reaches end of file marker. Now write mode. Write mode. So opens a new file for writing. Opens a new file for writing. So it is a new file which is having no content, no data. So that is why end of file is at the beginning. File marker positioned at beginning of the file. So this is the new file which we are going to write. And next, append mode. Append mode. So open existing file for writing or creating a new file. Open an existing file. So already there is a data, right? So EOF is the end of marker. So here there are some contents here. So the file marker positioned at the end of the file. From here onwards, the data will be written. The data will be written. Now mode R opens a file in reading mode. There are several modes. W, writing. A, append, open a text file in append mode. R plus, open a text file in both reading and writing mode. Another mode, W plus, open a text file in reading and writing mode. A plus, open a text file reading and writing mode. RB, so it's for binary file. So open a binary file in reading mode. WB, opens a binary file in writing mode. In append mode, opens a binary file in append mode. So for binary file, we are using B, RB, WB, AB. In the similar way, RB plus, WB plus, AB plus. So opens a file in both, binary file in both reading and writing. So these are the different modes available. So we can open a file in any one of the modes. So next, closing a file. So after all operations on a file have been completed, it must be closed. After performing, suppose we have a notebook. First we have to open it for reading or writing. After opening it, we can read or write it. So after all the operations are completed, writing and reading completed, we have to close it and keep it into the bag, right? So in the similar way, here files also. So all outstanding information associated with the file flushed out from buffers, all links to file broken, ensures accidental misuse of file prevented. So for these reasons, we have to close it. If you want to change mode of file, then first close and then open again, right? Suppose presently you are in the reading mode. You are opening a file in reading mode means just you are only reading, we are performing only reading operation. If you want to perform writing operation means you cannot do it directly. First you have to close it, then again open the file in writing mode. So that is. So for that you need to close it. So pointer can be reused after closing. Pointer can be reused, right? So the syntax for fclose function is fclose of file pointer we can use. Fclose of file pointer.